Alrighty, here's the notes for section 4, chapter 2. It's on axioms of order, so it's like the idea of greater than or less than. Establish that. We go with there's a trichotomy for all of our x and y of real. For all of our real x and y. It's a terrible R. Either x equals y or x is greater than y or x is less than y, but only one is true. So it's like if we have a real x, real y, it's relatively intuitive. Either they're going to be equal or one that's going to be bigger than the other, which is what these two statements are telling us. Then we can establish statements based off of our statements of equality. So we have reflexive, symmetric, and transitive. These are all properties of equality. So this says A equals A. Then we have if A equals B, then B equals A, and then transitive, if A equals B and B equals C, then A equals C. We have all these for equalities, but we only have two equivalences for inequalities. So we have what we do not, and the one that we don't have is reflexive, because think of the statement A is greater than A, it just doesn't make any sense. But the other two have equivalence. First one we have is pseudo symmetry. I don't know how to spell pseudo, so we have to deal with whatever the heck this mess is. That states if A is greater than B, then B is less than A. So you see, we did flip them, but the reason it's pseudo is because we also had to flip the inequality sign. Then we also have transitive property of order, which states if A is less than B and B is less than C, then we have A is less than C, which is basically the exact same thing as this, except all we did was sub in one of our inequality signs. Then we have our two ideas about like the addition property of equality and multiplication property of equality. We also have equivalence for inequalities. We have addition property of order. We have the multiplicative property of order. So this states is that if A is less than B, that means A plus C is less than B plus C. And what this states is that this states that A is less than B, then A times C is less than B times C, but there is a caveat. The caveat is that C is greater than 0. So it makes sense if you have 2 is less than 3, but you have C equals -1, -2 is not less than -3. And so what we have to do is figure out what do we do if we have the negative. And if you go back to like your algebra 1, algebra 2, actually probably algebra 1, you know that if you multiply by a negative, you have to flip the sign. But now, using those rules we just established, we're actually able to prove it. Yeah, so what we first have to do is prove a lemma relating to the idea that for all real B's, if you have negative b is greater than 0. Oops, radius b is greater than 0, then oopsies. Yeah, that's right. If b is less than 0, then negative b is greater than 0. We can actually prove this. We have b is less than 0, given b plus negative b is less than 0 plus negative b. And this is, remember, our addition property of order. And so then we have 0 is less than 0 plus negative b. That's just the additive inverse. And then 0 is less than negative b. That's the additive identity. And then we have negative b is greater than 0, but over here 0 is less than negative b. So we can go back and use not our symmetry but our pseudo symmetry and state that that means that negative b is greater than 0 using pseudo symmetry. That's what we'll do since I can't spell pseudo. P dot symmetry. Now this lemma is actually quite useful as it tells us what we want to do when we want to multiply both sides by a number, but that number is negative. And what we call that is the sign flip theorem. And that's the same thing. It's for A, B, and C that are real, and C is less than 0. We have is A, if A is greater than B, then AC is less than BC. And so this is saying if you multiply by negative on both sides, you have to flip your inequality sign. But like what we just said earlier, we can prove this one as well. We just start with our A is greater than our B, that's our given. Then we can use the multiplicative property of order and multiply both sides by negative c, since we know negative c is going to be a positive in this case, which means we're able to use the multiplicative property of order. Then we can reorder this into negative ac is greater than negative bc, and that's multiplication is associative / cumulative. I'm just too lazy to write out all the steps because it's like 4 or something to rearrange it that way. And then we can add BC to both sides. So you have BC minus AC is greater than negative BC plus BC. That's our addition property of order. Simplify the left side into 0 because that's the additive inverse rule. And then we can add AC to both sides. AC. And then since I'm running out of space, I'll just do the additive inverse and the additive identity into one step. BC is greater than AC. And we can use our pseudo symmetry. Oops, this should be down here. And then this should be additive property of order. If I have to write that down, that should be in this step. And we have AC is less than BC because of our pseudo symmetry. And once you have those laws, you're able to manipulate you're able to manipulate inequalities in a lot of different ways just using logical expressions. You don't have to do algebra. I think that's it for the axioms of order. Bye.